All right, so welcome to part 3 of the practice 4A test, practice 4A test. So I lied. I said I was going to do a whole section on geometric sequences, but there's really only one question on here on geometric sequences. So we'll do some geometric and exponential, and then the last section will be some of the constructive response problems. Okay, so a geometric sequence is shown below: 2, 8, 32, 128. Use the explicit formula to find the 8th term. So first thing we want to do is write the formula. We're going to start with a sub n equals. We're going to use our, well actually if you're not sure what the formula is, it's a sub n equals a sub 1 times r to the n minus 1. A sub 1 is the first term. So here my first term is 2. R is my common ratio. So what do I multiply 2 by to get to 8? 4. And then 8 times 4 is 32, and 32 times 4 is 128. So my common ratio is 4. So this is my explicit formula. A sub n equals 2 times 4 to the n minus 1. Then to get the 8th term, we're going to plug 8 in for n. And this is 4 to the 8 minus 1. 8 minus 1 is 7. So that's 2 times 4 to the 7th. I don't know that off the top of my head, so we're going to do that in the calculator. 4 raised to the 7th is 16,384. There we go. And then times 2 is 32,768. All right, that's it for geometric sequences. Make sure you know how to tell if a sequence is geometric, and that's if it has a common ratio. And make sure you know how to write the formula and how to plug something in. Shouldn't be too bad. I think that is one of the easier pieces of this test. Okay, number 18. A new car depreciates or loses value each year after it's purchased. That's true. If you buy a car, it's going to be worth less the second you drive it off the lot. A general rule is that a car loses 10% of its value each year. Chris bought a new car for $27,000. Here is the function that models that. How much will Christopher's car be valued after 10 years? So if you're looking like, okay, well, where did the 0.9 come from? Remember when we did compound interest and you had to add your interest to 100% of your bank account? This time we're losing 10%, so we're subtracting 10% from 100% of the car. So 100% minus 10% is 90%. So each year the car is only worth 90% of the year before. Okay, so if we want to figure out how much his car is worth after 10 years, we're going to do 27,000 times 0.9 raised to the 10th. Okay, and then that's just calculator work from there. Okay, so 27,000 times 0.9 to the 10th. And now we are down to $9,414.32. Okay, and that makes sense. A lot of people are thinking, okay, well, if you lose 10% each year for 10 years, you're down to 0%. But your car, you're not going to have a car that's worth absolutely nothing. Even like my Ford Ranger that I had when I was 15, still worth at least like $300. Maybe it's worth that much. We'll see. I don't know. All right, let's go on to 19. 19, identify a function that represents exponential growth and explain how you know it represents exponential growth. So our B value, or our ratio, for it to be exponential growth, the ratio must be greater than 1. So if we wanted a function, we could do f of x equals, I don't care what your initial value is. Make something up. I don't care. Let's do 5. times. Now my common ratio has to be something greater than 1. So let's do 3. And that's raised to the x. So my ratio is greater than 1. My b value is greater than 1, which means this is growth. And this number could be anything. This could be less than 1. This could be a -5. Or a, let's see. Probably wouldn't do -5. You could do a fraction though. You could do 1/5. Doesn't matter. That has to be greater than 1. The ratio. Alright, so for exponential decay, the ratio, a lot of people are just going to say it has to be less than 1, which is partially true, but it can't be negative. A negative ratio is not going to look like a J-shaped curve, because when you multiply by negative, if you multiply a negative times negative is a positive, well then that positive times a negative is a negative, and then that next one is a positive. It jumps up and down, so it's not going to look right at all, ever. Try graphing it on Desmos and see what happens. It's going to be super crazy looking. Alright, so B, identify a function. Okay, alright, so ratio has to be between 0 and 1. Can't be negative. It has to be more than 0 but less than 1. So here, let's do g of x just to have a different variable. G of x is equal to, I don't care what your initial value is. Let's start with a big number. Let's do 25 times, let's do like 7/18 or something. I didn't want to do 1 over because I wanted you to see you could have anything as long as this is less than 1. I don't want to say as long as it's a fraction, because you could have a fraction that's larger than 1, but anything less than 1 raised to the x will work. So here, my b value is between 0 and 1, which means that this is exponential decay. Actually, I'm looking at b. Let's change this right here from growth to decay. Okay. All right, so number 20. Number 20. Match the function with the graph and explain. So there's a lot that you can look at here. You have a -2 and a +2. That -2 is going to bring things down. That +2 is going to bring things up. We have a 3 and a 4, so those are our initial values. But really and truly, the one thing I want you to look at is that common ratio. This is between 0 and 1. So this is a decay function. So if I look here, one of these is growth and one of these is decay. So if I look, for it to be decay, it has to decrease from left to right. So this is decay. It matches with graph, or it matches with function A. This one, it increases from left to right. So this is exponential growth. If I look, my b value is greater than 1. So that means this is growth, which means this matches with function b. Okay. All right, then 21. To be honest, I am not sure if this means to match it with items 19 or items 20. So let's talk about, because that is actually going to make a difference. Actually, your domain for items 19 and 20 for all of these is going to be the same. Your domain for exponential functions should be all real numbers. Or we go from negative infinity to positive infinity. Okay? if I look at my graphs, this is going to go to the left forever. I know it looks like it's going to go straight up, but it's still going to go curve slightly to the left. This one, as it goes down, is going to go to the right forever. Okay, so there's not a value in my x's that is going to just skip and not have a y. So I'll be able to do, so for the domain for all four of these, it's going to be all real numbers. The range is where it gets funky. So if we're looking at number 19, which were the two that we came up with that didn't have a plus or minus at the end. Our graphs always get closer and closer to 0 but don't touch. So my range is going to go from 0, but it's not going to actually touch 0, so we won't have an equal to bar. And it's going to go all the way up to infinity. Okay, so because our graphs do this, it goes almost straight up, but it doesn't actually touch the 0. And same if it goes the other way, same if it's decay. I'm sorry, growth. This is decay. Now, numbers 20 are going to be a little different, because if you look at A, here's 0. It's not going to 0. Where is my arrow going to? It's going down to -2. So instead of 0 is less than, we're going to have -2 is less than y, is less than infinity. And then on B, again, this is getting closer and closer and closer to +2, not -2 or not 0. It's leveling off at 2. So this is going to be 2 is less than, y is less than or equal to infinity. So these numbers right here are is what the graph approaches, or what the graph levels off at. Okay. All right. So these two are a little tricky. This one we're used to. These two are a little tricky, but we added, if you look at the functions, we added 2 and subtracted 2. So that's why it's going closer to 1 instead of 0. All right, so I'm going to stop the video here. The very last section should be 4 different constructed response. I hope these videos have been super, super helpful, and hope you are studying hard. So good luck, and I will talk to you soon.